All right. Well, good morning, all you wonderful people. All right, let's see what we got. Graph quadratic functions by identifying the axis of symmetry and the vertex. Determine if a parabola has a maximum or a minimum. And this next one we'll probably have to wait until tomorrow before we get to it because it's going to rely on some of the things that we've covered today. So let's see what we need to know about graphing quadratic functions. So the very basic thing is the standard form of the quadratic function. The quadratic function in standard form looks like this. So it's as easy as A, B, C, but the more important thing, and this is again more important, is that the x has to be in descending power. So 2 power, 1 power, 0 power. So there's nothing there, so it's considered to be a 0 power term. And be careful with this because a lot of times, especially with this lesson, there will be a skipping of certain terms. Certain terms will be missing. So it's important that you, again, remember that it really depends on which power it's paired with in terms of x. And a quadratic function creates a U-shaped curve that we call a parabola. So parabola is this thing here, and it says to graph it. So use your graphing calculator, which you can use your graphing calculator. But in this case here, I am going to use, because in this point right now, I cannot really give, I can't give calculators to everybody, but that's okay though. We have, if you're online and you're watching this, you have our old friend Desmos here. So I'm gonna go ahead and go over to Desmos. Click on that, and we are going to input the first function here. So we have x. Oh, and you know what? We need the square. So to type in the square, you're going to need to push this keypad button, and it's going to be this one here. So it's going to have a square. So we're just going to put that puts a square on whatever number you're on. And now let's see. The next thing would be plus 2x. minus 5. And we're going to notice a few key features about the graph. Well, for one thing, an easy thing to kind of get would be the zeros from the graph. So we can see that it's crossing the x-axis at 2 points here. There is also going to be a vertex. So if you remember from the last lesson of graphing absolute values, the vertex is the point where the graph will turn. They call it the turning point. There is also a y-intercept right here at -5. And just kind of a quick thing, the y-intercept is still just like if you remember linear functions like y equals mx plus b. This last number is usually going to be your y-intercept. So that's kind of like where the line crosses here, but it's a little bit more complicated in graphing these than a linear function, but that is one of the nice things is that at least one thing is going to be different. All right, now I'm going to go ahead and do the next one. And for this one here, and this is the one that's also on the packet, that's going to be -x square. So I'm also going to need the keypad. Push the square button. You're also going to notice that this one is different in a major way, and that it's different because it's opening downwards. So here, if I take off and put on the negative, you're going to notice that it flips the direction of the parabola, but in this case we need a negative. So I'm going to go ahead and leave the negative on there for now. So negative x squared plus 3x plus 7. And again, we do have our y-intercept here at 7. Vertex is kind of an odd number. It's over 1.5 up 9.25. So sometimes that also happens. Now, there's also going to be another kind of big difference between the negative and the positive, because remember, that was one of our objectives, was to find out whether a parabola will have a maximum or a minimum. And this one's a little bit tricky only because it's opposite of what you would think of. Well, let's go ahead and I'm going to go back to the Let's go back over to the lesson. And if I said, you know, a value is positive, so right here it says if the a value, that is the first number with the x square, is positive, the parabola will open upwards. So it's kind of like a cup, okay? If you have a cup, it can basically hold liquid or whatever in there like this. So again, it opens upwards. And those have a minimum. So just like if you were to imagine placing something in that cup, it would sort of just go to the bottom and stay there. And again, it's opposite, because if a is negative, you will actually have a maximum. So this is like a mountain. If you try to climb a mountain, you will reach the top and you can't go any higher unless you bring a chair or a ladder with you. But either way, there is a maximum height that you can reach. And then if you keep going along that path, you're going to have to go down the other slope, the other side of the mountain. So again, that one's a little bit backwards. But again, you're measuring it from which way it opens. Now, I hope that's everything that we need to know from here, because we're going to have to keep moving. And some of the other things that we're going to do is, so think back, and there's a reason I kind of did this. There's supposed to be a few lessons in between now and going into what we're doing here. So the last lesson we covered was graphing absolute value functions, and there's going to be a lot of similarities between absolute value functions and graphing quadratics. And again, I did that on purpose. So we skipped a couple of lessons just to kind of keep the momentum going, keep the ball rolling on this. And you still have an axis of symmetry. So I didn't really have to say axis of symmetry at all during the last lesson, but I did because it's a pretty good concept to get. So again, that means that symmetrical means that it's the same on both sides. So like this water bottle, well, if you minus the stickers, would be symmetrical on both sides. And you probably already know what symmetrical means, right? It means the same on both sides. So you still have that thing. Now, finding the axis of symmetry is a little bit different. There you would look at the absolute value expression. Here, we're going to look at the formula. So there's a special formula for finding the axis of symmetry, and that's going to be this thing right here, the negative b over 2a. And we're going to use the standard form a x squared plus bx plus c, and we're going to put those corresponding numbers in for a and b. We're also going to have that turning point called the vertex again. So when we graphed the last ones, I showed you where the vertex would be. So graph the vertex, and again, it's going to remind you again that the lowest point is called the minimum and the highest point is called the maximum. And again, be careful with this, because again, it does go opposite the way you would think sometimes. So best thing to do is what I kind of draw like a little mini graph on it. And that way I know whether it's going to have a minimum or a maximum. So label these parts on the graphs above. So I'm going to have to go back to the last one here. So again, minimum is going to be this little point down here. Maximum is going to be this point here. Now, when I showed you the graphs on Desmos, so in this case, this is just a rough approximation. I think maybe the real graph would be a little bit lower on this, depending on how you count it, but it would look very similar to that. All right, but now we're going to have to go into drawing parabolas in a much more precise manner. So a really quick thing about parabolas. So with parabolas, it's actually very common to see them around you. So if you were to take a chain and suspend it, or a rope or anything, it would form an upside down parabola. That's just the natural point, the natural shape that it just goes into. If you were to throw an object, and you probably have done this, if you take an object and you throw it up in the air, it kind of goes up really fast, then it starts slowing down, and then it starts falling, and as it starts falling, it falls faster and faster. And that motion is represented by a parabola. So parabola, same thing. If you look at a parabola, it would be shaped like that. Let me see if I can go back to that other one really quick. So if you were to throw something in the air, it would go up, up, sort of slow down, and then come back down really fast. Okay, so let's go ahead and start with the first exercise, and let's see what it says. It says to determine whether each function has a minimum or a maximum, then find the axis of symmetry and vertex. Okay, so in this case here, I'm going to do something a little bit off of the normal path, and I'm going to start with number 4 and then work my way down. Partially because I think that certain students have been getting confused, and I don't know, but I can understand. They haven't told me it's confusing, but I can understand how and why it would be. All right, so let's go ahead and look at this. Right, I'm going to start with number 4, and first thing we're going to do is we're going to determine whether it has a minimum or a maximum. So look at the a value, which in this case, there's nothing there, which in this case means that it's positive. And remember, a positive graph opens upwards. So it's going to look like this. So again, positive, if I ask a student, okay, if a graph is positive, does it have a minimum or a maximum? They're going to say, well, they're going to say the wrong thing, because usually when we think of positive, we think of something maximum. But again, that's opposite of what you would think of, because remember, it's which way the graph opens, which in this case it opens upwards, which means that we're going to have a minimum. All right, so that's the first thing. Let's go ahead and work on the second thing, and that is to find the vertex. So to find the vertex, we're also going to have to find the axis of symmetry, which we're going to need the axis of symmetry formula. So let's take our b value, which in this case is the middle number. Now this one's also a bit of a tricky one, because if I look at the b value, it's negative. But if I look at the formula, it also has a negative. So one negative comes from the formula, and the 8 also brings another negative, so I end up with 2 negatives. And then 2a, so let's go ahead and go 2 times 1. 2 times 1 is going to be 2. And the opposite of negative 8 would be positive 8, or it would be double negative. 8 divided by 2 would be 4. So I know the axis of symmetry is at x equals 4, and that would be a vertical line at 4. Okay. So I know that there's going to be a vertical line at 4, and it's opening upwards, so it's going to look something like that. But I also need to know where the vertex is. Where does it turn? Because it could turn up here, or it could turn way down here. So to find the vertex, I'm going to have to take the original equation and plug 4 into it. So that'd be 4 squared minus 8 times 4 plus 9. All right, so 4 squared is 16. And then 8 times 4, which is 8 times 4, that's be 32 plus 9. 16 minus 32 is negative 16. Negative 16 plus 9 would be negative 7. I'm out of space here, so. But you would just evaluate it. So plug in your axis of symmetry for x and then evaluate it. And then my axis of symmetry would actually be the same as the x on the vertex. So to find the 4, so if you imagine, the middle of the graph, we go over 4 down 7, and that means that our vertex is going to be here. So that means our parabola is going to look something like this if I were to graph it on our standard graph. But there we go. We have all of them set to go. Now again, there are going to be some tricky ones where you will be missing some of the values. This one here we can see has 1 term and 2 terms. So there are 2 terms. This means that one of them is missing. So what I would imagine a lot of students would do is they would go negative 7 over 2 times negative 2. But there's something wrong with this. And that is 7 is not the b-value. Remember, I said that it's more important to know what power it is. 7 does not have x of any power. So actually this means that there is a b-value, but that b-value is 0. There's nothing here. If I were to write this problem all the way out, it would probably look something like this. Their 0 would be right here. Now, anytime you have a 0, it doesn't really matter what the bottom number is going to be, because 0 divided by any number is always going to be 0. So we have our axis of symmetry, and I almost actually skipped a step, but we'll come back to that later actually. The next thing we'd have to do is plug 0 back into the original equation. Zero times 2 is, or well, actually this would be 0 squared. Now, in this case here, I have two things going on. So we are going to have to go back to basics on this one and think of PEMDAS. So I have, this 0 has two things happening to it. It's being multiplied by -2, and it's being raised by an exponent of 2. So PEMDAS says we should do the exponent before the multiplication. So if we square 0, we get 0, and then if we times -2 by 0, we still get 0. So this means our vertex is going to be 7. And axis of symmetry is going to stay the same number from what it was up here. Now again, I did skip the minimum and maximum, but we did find our vertex. So let's go ahead and look at our A value. In this case, that's the most important part to determine whether it has a minimum or a maximum. And in this case, that means the graph opens downward. So I drew a little mini graph here just to show what it would look like roughly. And we see that it's opening downwards. And if I were to go to the turning point, it would be on top. So that would be the maximum. Okay. Now for this one here, we have a similar thing to number 3 because we only have 2 terms. But this one's a little bit different. It's a little bit different because we have the b value. See, our b value is right there. That x is telling me that this is the b value. So let's go ahead and plug it in. So -6 over 2 times -1. So -6 over -2. And negative divided by negative would be positive. 6 divided by 2 would be 3. Oh, in this case here, we also have a negative here in front. Since we have a negative, that means we're going to have a maximum with this graph here because, again, it's going to open downwards. All right, now back to work here. So axis of symmetry is at x equals 3, which actually I just noticed that I did not put the x equals here. So since x value is 3 in my ordered pair, so remember that an ordered pair has 2 values, x and y. In this case, I don't know what the y is, but that's what we're going to find out now. So I'm going to take my original equation and plug in 3. And in a sense, what I'm doing is I'm asking the function, where is 3 at, where's the y value at 3? So if I plug in 3, why do I get out? So it's still inputs and outputs. So -3 squared plus 6 times 3. Right, so now again, this is still the same thing. We still have to use our PEMDAS because I have an exponent, and in a way, this is multiplying by -1. And you have to put the parentheses there because if I put the negative on the inside, you're going to get a different answer. Because here, if I square it like I should, 3 squared is 9. But the negative is not affected because it's on the outside of the parenthesis. So again, just like absolute values, since it's on the outside, it doesn't get washed, as the analogy I think I said on that one. So 3 squared would be 9, but that negative is going to jump right on. Plus 6 times 3, that would be 18. And this is like 18 minus 9, which would be 9 for our value here. So we got 9 right there. And we have all our pieces. And again, I decided to go backwards because it makes it a little bit, I think students would have an easier time understanding the missing parts when they already know what the whole thing looks like. So I think when I do this type of problem first, they're like, doesn't make any sense because they don't know how to put it together. But in this case here, there is no B value and there is no C value. So if I were to try to put it into the formula, well, it doesn't matter what my bottom number is because it's 8. I'm sorry, even if it is 8, 0 divided by 8 is still going to be 0. So that I know my axis of symmetry is going to be at 0. But again, I keep going straight for that. And normally when you're graphing it, normally you don't really need to know whether it's got a minimum or a maximum first. So I'm going to do this really quick. So we see that it's positive. So that means it opens upwards. And that means that it's going to have a minimum. And again, that's backwards because if I said a positive function has a minimum or a maximum, students are mostly going to say the wrong thing because usually when we think of positive, we think of something that's high up. But again, backwards. Axis of symmetry, x equals 0. And let's plug 0 back in here, which if I did that, 4 times 0 squared. Well, 0 squared is 0, and 4 times 0 is going to be, well, 0, not 4. Okay. I said 4 when I was writing it, so it probably, in my mind, does that. Anyway, there we go. So that's the first type of exercise. Important thing is find the axis of symmetry, then find your vertex. And this is kind of fitting into a different form of graphing that we're actually going to cover probably Thursday or sometime later this week. And that's called vertex graphing, or graphing by vertex. But this is still useful though. And actually we're going to still kind of use a lot of the same steps that we learned from graphing absolute values. So first thing we got to do is find the axis of symmetry. Okay, place that number that you got for the vertex in the middle row. Graph some numbers up and then some numbers down. Complete the table and do your best to connect the dots, which would be basically the graphing function. So again, it's very, very similar to what we did recently with absolute value functions. And again, I did that on purpose. So let's go ahead and start graphing some of these now. So with this one here, I'm going to start with this one first, just because we can see here there's A, B, C. So I have all three terms. None of them are missing. So this makes it pretty easy to kind of understand where these pieces come together. So let's go ahead and I'm going to start graphing it. First thing we're going to have to do is find the vertex and the axis of symmetry. So this is actually your axis of symmetry formula, but we're going to use it to find the vertex as well. So let's go ahead and take negative b, which in this case is -6. And in this case, I end up with two negatives because there is a negative with the 6, and then there's also a negative with the formula. All over 2a, which in this case, we don't really see an a value, so that would be 1. And opposite of -6, or, well, yeah, that is the way you would say it, opposite of -6. But in this case, there's two negatives, so it's like negative times negative, which would be positive over 2. And that would mean that our axis of symmetry would be at 3. Okay, so we have 3. Take that 3 and drop it into your middle row. Because again, this is our vertex right here. Let's number some down and then number some of them up. So again, just like we did with the last one, we're going to go ahead and take these numbers and start plugging them into our original function until we have our table full. Okay, so let's go ahead and start with 0. So I'm going to plug in 0 into the original function. So I got 0 squared minus 6x, which is 0, plus 11. All right, and this is going to be kind of easy. Now, I kind of hate that I have to erase these each time. I want it to look like the packet, but I know sometimes you're just going to have to write this somewhere else. But hopefully, again, you get the idea. The idea is the more important here, and that is to just put them in and see what comes out. Now, for this assignment, it says to graph and state the domain and range, but you are also going to have to fill out the table. Now, I know some students will use Desmos to graph it and just copy the points, but I'm going to mark you down on points if you don't have the table. So make sure you fill out the table, and you are going to need to work on each of these like this, which is a long process. And like I said, there are some easier ways to do this, but this is, again, graphing by table is the one that's easiest to remember. So anyway, I'm going to get back to this. So 0 squared is 0. 0 times -6 is still -0. Well, no such thing. But I get 11 out of this. So there's our first one. Let's go ahead and move on to the next one, which would be 1. So let's go ahead and put 1 in there. So 1 here, 1 here. 1 square. So 1 square is just going to be 1. -6 times 1 is going to be, well, -6 plus 11. Now what I like to do is I like to add the positives. So I have positive 11 and positive 1, and that would be positive 12. And that'd be like 12 minus 6. So that would be 6. You can go from left to right like the directions tell you to, like PEMDAS tells you to, but you would get -5 plus 11. And that would still give you 6, but just a little bit of extra work. Anyway, whatever works for you. But for me, I like to put the positives together and the negatives together. So let's continue on. So the next number will be 2. So I'm going to put 2 in there. So that'd be 2 here, 2 there. 2 square is 4, and 6 times 2, well, it's a -6, so that'd be -12. And I'm going to put 11 and 4 together so that I get 15. 15 minus 12 is 3. And just keep doing this down the line. So next number is going to be 3. So put 3 here. 3 square is 9 minus 18. 9 minus 18 is going to be -9 plus 4, which 11 minus 9 would be 2. And now, since this is our vertex, we can imagine it that it's going to go back the other way. So it's going to continue the pattern of 3, 6, 11. So the next number would be 3, 6, and 11. If it doesn't, then that's kind of a sign that maybe there was an error somewhere. So let's go ahead and put 4 in here. 4 over here. So 4 square is 16. And then 6 times 4 is 24. And I can put these together. So, but in this case, it probably wouldn't help out that much because I think 16 minus 24 is going to be a little bit easier. So I'm going to go ahead and do it that way first. So 16 minus 24 would be -8 plus 11, which would be 3. And again, that it should match out. And then 5, let's plug in 5. So 5 square is 25. -5 times, 6 times, -6 times 5 would be -30. 25 minus 30 is -5. 11 minus 5 is 6. Now for this one here, we can't graph 11, right? Because the number only goes up to about 8. Since I can't graph 11, that would be off the graph. I'm going to go ahead and just skip that part. Any number that would go off the graph, I'm going to go ahead and just skip those. Because even if it was wrong, let's say that this number isn't 11, which it is. Like if it was 12 or 13, it probably wouldn't affect the way the graph looks. So in this case, again, the table's good, but the graph is really the important part. So anyway, let's go ahead and graph this. So 0 and 11, okay, that's off the graph. 1, 6, so over 1, up 6. Next one is 2, 3, so over 2, up 3. 3, 2, so over 3, up 2. Over 4, 3. 5, 6, so over 5, up 6. And then 6, 11 is off the graph. It would be like maybe right there, as I'm guessing. But you notice that we have our enough dots that we should be able to graph this now. Now, one thing I'll often see, and this is what I don't want you to do, is I see students drawing straight lines like that. Okay, graphs, parabolas are not straight lines. They're not connecting the dots. This is not a kindergarten activity book. Real parabolas have curves. So it's going to be a constant curve from here to there. And just to kind of illustrate this point, I'm going to go back to one of the other graphs really quick. And see, there's no straight line. It doesn't just go from like 1 to 2 or anything like that. If I were to pick a point on this line, it gradually changes. So the relation between x and y is gradual. So let me see if I can find that number again. So 3 and 7. So 3 and 7, even though it will cross another point, like maybe here, for 3, all right, it's from there to there, there is a curve here. It's not just a straight line from one to the other. Okay, and like I was also telling you, it's like a ball being thrown through the air. I mean, a ball doesn't get thrown in the air, stop, then continue, and then go faster, and then slower, and then up, and then stop, and then down. You know, it doesn't do that. It doesn't do that. So that's why you have to have your parabolas graphed in nice curves. All right, so let's go ahead and go with domain and range. And I think in this case here, we're very safe in saying that our domain would be all real numbers because it is a function. The quadratic function is a function, and function means that it does not have any holes, gaps, or repeats any of the x values. That's the definition of a function. Now you can have parabolas that will have holes in them, but they're going to look way more complicated. So if you can see the function and it looks like it's in standard form, and you don't see any weird fractions or anything like that, then you're probably good. So we're pretty much safe in saying that it's all real numbers. Range, as always, is going to be a little bit more difficult because the range does not have to really follow certain rules. But in this case, I think the rules are going to be pretty simple. So we want y values that are only possible are 2, right? If we look at the numbers here, it goes down to 2, it stops, then it goes back up. So 2 is the lowest number we can get. So we want y values greater than or equal to 2. Those are the only y values we have. We can only pick 2 or higher, that's it. You know, if I wanted to plug in a number so that I could get 0 or -1, can't be done. All right, it's out of range, can't get there. All right, so let's go ahead and do this one. And like I said, this one might be a little bit of a tricky one because I know some students are going to be like, well, where's all this coming from? So the b value, there's nothing there. Sort of like the b value that we saw with one of the other problems in the past was that it's not there. So I'm going to go ahead and put 0 over 2 times -3. That'd be 0 here. So any number, if you take 0 and divide it by any number, you're always going to get 0. And that means that our axis of symmetry is going to be right here. And you don't need to draw that. I did not draw that for this one here, but at least we can tell if it helps. And in this case, you can leave it on if you want, because axis of symmetry is actually something that you, in most cases, do need for parabolas. But at least we know that this is going to be the middle point. So let's go ahead and number some down and number some up. And same thing, we're going to plug in each of these numbers until we fill out all of the graph. So this is the only place I have to write it. So sadly, I am going to have to erase it. -3 times, and in this case, I also have -3 as my first number. That's going to be squared. All right, so again, follow your order of operations. Exponents before multiplication, because that's how PEMDAS goes. -3 times -3, it would be +9. Now in this case, I'm going to have to multiply -3 times 9, which would be -27, which gives us our first number here. And -27 is off the graph, right? I cannot graph up -27. So even if I'm wrong, which I'm not, I'm pretty sure it is -27, it's not going to really affect the graph. So just to keep things moving quickly, I'm going to go ahead and just place it here. And any number that's higher than 8 or lower than -8 are also going to be just filled in automatically. So the next one here I'm going to have to get to would be -2. So -2 squared would be 4, and that would be -12, which again, this one is also going to be off the graph. And I'm pretty sure that it is -12. I mean, this is kind of a simple one, so I don't think there'd be a whole lot of issues that could cause it to go really wrong. But again, I don't want you to get into this habit all the time of doing this, because you know, mistakes do happen, and it's important to catch yourself when that happens. All right, so I'm going to start with the next one, which would be -1, which would be -1 square. We get +1 times -3, which would be -3. Now in this case, this one will fall on the graph, so I'm going to go ahead and continue with all of them here. So I'm going to go with 0. So 0 squared would be 0. And then, well, 3 times 0 would be 0, or anything times 0, really. And then here I got 1. So I'm going to go and take this and put 1 in there. Which 1 squared is still 1. And then I get -3 times +1. And you notice that in both cases, the square made them both positive. So that's kind of where you get that go back to where it came from on the parabolas. So anyway, again, these three are going to be the only ones that we can put on the graph. So -1, -1, -3, -1, -3, 0, 0, and then this point here would be over 1, down 3. Let's graph that. So it's going to be a very narrow graph. It's going to be looking like that. Maybe not exactly, but at least you can see it pretty well, what it's doing. Domain. I don't see anything funny. And again, this is a function, so it is going to follow the definition of a function. But range, again, we got to look for what we have. So we have a maximum, because the graph goes up, reaches a high point. We can't go any higher than that, then it goes back down. So we have to have y values less than or equal to 0, because all these numbers on both sides are all going to be less than 0. The highest number you can pick is just going to be 0 itself. So that's why, well, that's why the range is going to be what it is. All right, moving on. Another one that's going to be kind of simple, I think. Well, let's go ahead and find the first thing. So again, the first thing is to find the axis of symmetry. So we're going to use our axis of symmetry formula. -8, oops. In this case, there'd be two negatives, one in the formula and one with the 8. all over 2a. So in this case, my a value also just so happens to be 2. And let's see, opposite of -8 is +8. And then we have to divide that by 4, and we get 2. Now, in this case here, my axis of symmetry is going to be here. And you can mark it or don't have to mark it. In this case, I'm going to go ahead and mark it just because it's pretty much already there. And then start with that number in the middle. And again, number down and number up. Okay, now we have to get our original formula and start plugging in these numbers that we have here. And this one's going to be a little bit tricky because I have 2 times -1 squared minus 8x, which I'm going to replace that with -1, plus 6. Okay, and then let's go ahead and fill this out. So -1 squared would be +1. Negative times negative would be +8 plus 6. And now 2 times 1 is 2, 8, and 6. And in this case here, I get 2 plus 8 would be 10, and that would be 16. And again, just to keep things rolling, I'm going to go ahead and put 16 down here because it would be off the graph anyway. Let's go with 0 now. So let's go ahead and put 0 in here, which is going to be pretty easy because 0 squared is going to be 0 times 0 is nothing. So I got 0 plus 6, which is going to be 6. So 6 is a number, so I'm going to keep going. It is a number that we will find on the graph. Okay, now we got the next number, which is going to be 1. So we'll put 1 in here. 1 and 1. -8. And then here I got 1 squared, which is going to be 1. And then we're going to have 2 minus 8 plus 6. I'm going to put my two positive numbers together, which actually looks like I'm going to get 8, which is going to be 8 minus 8, which is going to be 0. And again, if I'm not sure about that, I can just wait till I get to this one here and then see if I get the same answer or a different answer. All right, now let's go ahead and plug in 2, because that's the next x value that we're going to pick is going to be 2. So 2 squared is 4, and -8 and 2, put those together, and that'd be -16. 2 times 4 would be 8 minus 16. Again, I'm going to put my two positive numbers together, so that's 14 minus 6, so that'd be -2. All right, so we made it to the vertex. The next number should be 0 and then 6. So let's put 3 in here. So putting in 3. 3 squared is 9. And 8 times 3 would be 24. So 2 times 9 would be 18. -24 would be, well, stays -24. Put my two positive numbers together. I got 6 and 18. That would be 24. 24 minus 24 would be 0. So there we go. I got that number here. So I know that's going to be the right number. I know there's no mistakes here. So I'm going to go ahead and put 4, and then we'll be done with this one here. Put 4 in there. 4. So 4 squared is going to be 16. And that's 32. 32 minus 32, which is going to be 0 plus 6. 0 plus 6 is going to be 6 again. So now it matches on this side. So there we go. At least for the parts we can see, we know that this should be good. 0, 6. over 1 up 0. Wait, is that right? Over 1 up 0? Yeah, I guess so. Over 2 down 2, so that's my middle point, my vertex. Over 3, 0, and then over 4 up 6. And if you look at the axis of symmetry, all of them are going to be the same distance from there. So it's 2 from here to here. On this side, also 2 from here to here. 1 from here to here, 1 from here to here. And if I could see the other one, it would be 3 on this side, 3 on that side. Let's do our best to draw a curve that goes through as many of these lines as we can. Sometimes when I'm drawing with the tool, I have to kind of go a little bit past to make the curve match. But again, it's got to go through as many of those dots as I can. Okay, but you only need to go to the edge. You know, you could stop your line right about there. But I have to kind of stretch it out. This tool that I'm using, that I use to draw the parabolas, is not really good for parabolas. It's close enough. It's really close enough to where you could say, okay, that's close enough, but it's not perfect. Anyway, so we got all real numbers because these arms, even though they're going up pretty quickly, they're ever so slightly moving side to side. And you would have like x to infinity, right? Because if I pick over infinity, I'm going to have to go up quite a lot. But yeah. Anyway, range. So range, look for your vertex. Your vertex will always contain your range. So we know that it contains -2. And we know that we're looking for y values. And the only thing we have left to do is find out, do we want numbers greater than y, which in this case is true, right? We want anything greater than -2. So 0, 6, 16, and all the numbers in between are all greater than -2. So the range is -2. And we're done with that one. All right, now this next one's going to be, well, maybe a tricky one because it is missing one of the terms. We have our a value, and then we have this 5. And again, be careful with the term that's missing, because you could be missing either B or C. Now you can't be missing A, because if you were missing A, then it would not be a quadratic formula, a quadratic equation, quadratic function. Okay, it would not be either any of those. So it's got to have the x squared. So the only two things that can be missing would be the B value, which this one is missing the B value. Since it's missing the B value, well, it doesn't matter what our bottom number would be, because you can't have -0, and 0 divided by any number is always going to be 0. So it looks like we're going to have another function with 0 in the middle. So as usual, number up, number down. -3. Oh, we're going to have to erase this because well, we're going to have to put in some of these numbers. So there's a negative right here, -x² plus 5. And I'm going to have to drop in -3. So again, this is like multiplying by -1. So this is -3², that'd be 9. But this negative is going to jump onto that 9 again. So I'm going to end up with -9 plus 5, which would be -4. So I'm going to put that -4 right here. And then keep going with all of the other numbers that we can get. So we have -2. I'm going to put -2 right here. So -2 times -2 would be +4. But again, this negative here is going to just jump right on. So that negative is still going to be there, and it's going to make whatever number comes out of that parenthesis negative. So 5 minus 4 would be -1. And then put in -1 here. So that would be -1 squared, which would be +1, but again, make it negative, so that would be 4. Plug in 0 now. Well, in this case here, if I did that, it would be 0 squared, -0. We can't have -0, so that'd be just 5. And then plug in 1 here. So let's go ahead and do 1. 1 square is going to be 1, which it's going to be negative. So it's going to be -1 plus 5, which in this case would be 4. So that takes care of our next number here. And I'm going to go ahead and put 2 in here. So we need 2. So 2 squared is 4. And this is 5 minus 4, which is 1. And the last one is going to be 4, which is on the graph. -4 would show up. So I'm going to go ahead and do all of them. And that would be no. 4 squared would be 16. So that'd be 5 minus 16. No. 4 squared is, okay, so that would be negative. That's a weird one. Oh, you know what? I know what it is. I went to 4 when the next number up should be 3. Silly me. All right, but in that case, I noticed something was wrong, and actually I noticed something else is wrong too. Now, like I keep saying, you should look at the axis of symmetry, and it should be the same pattern on both sides. So from here, we got 5, 4, 1, -4. Up here, I got 5, 4, -1, -4. Now, I did this on purpose so that way you could see that there is an error. And if I start graphing it, the error is going to become even more apparent. So -3, -4, would be like right there. -2, -1. -1 up 4, 0, 5, over 1 up 4, 2, 1, so over 2 up 1, and then 3, -4. And you can see one of these dots is not going to match the other ones. So in this case, you would say, okay, does this side look more like a parabola, or does that side look more like a parabola? Which in this case, you can easily see what happened is that this one went down when it should have gone up. And again, if you were looking at the table, you would have also noticed that it was not the exact same on both sides. So this was a negative. So again, that's just a way of doing that. So that's why I tell people not to autofill, because sometimes you will miss things like that if you use the auto, like if we just fill it in using the axis of symmetry. Because sometimes that does happen and you will miss something like that. Ah, darn it, too far. All right, so anyway, there we go. Now let's go ahead and get our domain and range squared away, which in this case here, domain is going to be all real numbers and our range is going to be y values. So we have a maximum, right? So that number goes up and then we have to go back down. So maximum means that we want numbers less than our vertex number. So our vertex number in this case is 5. So 5 is the highest y value we can get. Everything else is going to have to be lower. Oh, and what do you know? Another set done. Kind of weird. I think we're mostly done with this. My first hour, we actually did not have enough time to complete this. So I hope I'm not moving too fast. But my first hour also did have, they showed up late. I think they were like, the first person showed up 10 minutes late. And I was just about to push the close button on that. Because if you remember, I usually have that rule where if nobody shows up after 10 minutes, I usually just sort of cancel the lesson. And I think last week I did do that a couple times, and I think that's because we came back from spring break and a lot of people might have forgotten when spring break was over or something. But I did end up having to cancel a few classes. I'm getting a lot more people this week. I think a lot more people are knowing that Spring break is not continuing. Anyway. Ooh. Oh, before I go on with these ones, I'm going to kind of tell you a little bit on how you can check these. And how you can, another way you can kind of get a feeling of whether you're doing the right thing on your graphs for parabolas is to use what's called the rule of odds. So you know what odd numbers are, right? If I told you to list the odd numbers, the first one would be 1, the next one would be 3, 5, and then 7. And then it would also continue, but for most parabolas, you're not going to need more than 7 ever, mostly, unless you're graphing a really big graph. So start from your vertex and go between these two next points. I have to go down 1. To go to between the next 2 points, I'd have to go down 3. So from here, 1, 2, 3. And that's going to get me between the next 2 points. From here, I'd have to go down 5. So 1, 3, 5. 1, 2, 3, 4, 5. And that's going to get me between these next 2 points. If I want to get down here, if my graph was bigger, I'd have to go down 7. So I'd actually have to go down 7 in order to get to where it's going to cross over here. Now, this only works if you have an a value of 1 or -1. If you have an a value of 2, it's not going to work. But you can still make it work. You just have to double each of those odd numbers. So 1, 3, 5, 7 would go 1, 6, 10, 14. So if I look here, 2, then 6, and the next one would be at 10. So that's why you have that stretch. That's why you have that really narrow graph right there. So anyway, 1, 3, 5, 7. Let's go ahead and look over our first one. Oops, too far. In this case here, we have a 1 here. So this one should also work with the rule of odds. 1, 3, and then the next one would be 5, but that one's off the graph. Anyway, that's just a really quick way you can look at a graph and say, okay, well, it's looking off, but I can tell why it looks off. Anyway, let's go ahead and get back here. So first thing we got to do is look for the b value, which we have right here, because remember, b value is the number that is paired with the x to the 1 power, not just the second one in line, because you could be missing either of those. So -1 over 2 times -1/2. Oh no. Okay, so let's see, negative. Wait a minute, hold on. The b would already be negative. So actually you'd have a negative here, and then there'd be another negative with the equation. And like I said, I didn't actually get this far with my first hour, so this is the first time I'm doing this one here. So that would actually be +1 over, and then this would be 2 times -1/2, which would be also -1. 1 divided by -1 would be -1. So now we know where our axis of symmetry is. And sometimes I put it on the graph, sometimes I don't, because again, you don't really have to. But if it helps, like in this case, go ahead and put it in there. And you can leave it in there too. So number down and number up. So again, just one number in both directions, and that should be good enough. Okay, now let's go ahead and start filling in the formula. So this one's going to be a bit of a doozy. For this one here, you could probably turn it into a decimal. So you could put it into 0.5 or something like that. But in this case, I'm going to leave it as a fraction. And we have -4 squared as our first number minus, and I'm going to put -4 in here. That 4 looks a little bit off, so I'm going to do that 4 again. There we go. Now I am going to start evaluating for each of those x values. All right, so -4 squared. So remember, negative times negative is positive. 4 times 4 is 16. And if you times a number by half, really you are just dividing it by 2. And I said this before, I think we had 3 other lessons where it was like this, where if you multiply a number's reciprocal, so in this case we're multiplying to the reciprocal of 2, you would be dividing it by 2. even though technically you're multiplying. Anyway, let's go ahead and do this one really quick. So opposite of -4. So take away a negative. So if you take away a negative, that's good, right? If you have something bad and you take it away, that's good. So 16 times -1/2, that'd be -8 plus 4. And that would be -4. Okay, so -4 here. And because we don't have a 1 in the x squared, that means we cannot use the rule of odds. So we are going to have to do each and every one of these. So no shortcuts for this one. All right, next one's going to be -3. So -3 squared. So -3 squared, that's going to be 9. And it looks like we're going to have plus 3. So what is 1/2 of 9? And again, just to make things simple, I'm going to go ahead and go with a decimal. That might be a little bit easier for more people to calculate, because, well, say I guess you could say 4.5 or 4.5, and I think if it's a simple fraction, I think some people would be able to get it, but I know decimals are going to be one of the more common things. So in this case, I have 3 minus 4.5, so that'd be 1.5, but it would also be negative because my negative number is going to be bigger in this case. All right, I'm going to kind of pick up the pace a little bit. Next number we need is -2. So I'm going to put -2 in where x was. And in this case here, let's see, -2 squared, that's going to be 4. But half of take 4 and then divide it by -2. Well, you would get -2. But then this side's going to turn into +2. So you're going to end up with 0. Whew. And then last one's going to be -1. Well, you know what? I could make it the last one if I wanted to. So instead of constantly doing this, and you're also going to notice too that as we do this, this is just going to become positive anyway, right? So if I put +1 in there in a square, it's still going to be +1. Over here, same thing. It's going to get reversed. So it really is just going to go right back to where it was. So, oops. Let's see, -1/2 or -0.5. Oops, that 2 shouldn't be there. It should be a 1 for now. In this case, we would have 0.5. And again, just to move things along, go ahead and just fill in the rest of it. And you could use Desmos to check it. And again, I do recommend that you check it with Desmos. And be careful, because don't just copy the graph on Desmos, okay? Because you will need the table. Because that's one of the objectives, 1. And 2, it gives you a table, and the lesson is called graphing by table. So if you don't use the table, you're just sort of missing the whole point of the lesson. And again, graphing by table is probably one of the most reliable ways of graphing, because anything can be graphed by table, really, anything at all. You can use it to graph absolute values, linears, quadratics, or even 3-power functions, which we call cubic functions. All of those can be graphed by table. Anyway, let's go ahead and graph this here. So -4, -4, -3, -1.5, which is going to be about right there. -2, 0. So again, this one's going to be kind of a weird one. So we cannot use that rule of odds, which actually it is kind of the rule of odds, because the rule of odds says 1, 3, 5, 7. And if we were to divide each of these in half, so that'd be 1/2. Half of 3 is 1.5, 2.5, and 3.5. So if I take the half of each one of those, so look at it, see, it goes down half, down 1.5. So from this dot down 1.5, and then down 2.5. And the next one should be 3.5. So actually I could graph this one, go down 3, a little bit, 0.5, and then over 1. So I could graph it using the rule of odds, but again, And it depends on this number. Whatever your a value is, that's going to be multiplied to that. But again, if you do graph by table, that's going to be easy. And I'm only showing you the graph by rule of odds, just so that way you can kind of tell when something's a little off. So if you made a mistake, you know, it's a little bit easier to get. And in this case, I got so many points, it's going to be really hard to go through all of them using that tool. So I'm going to just draw this one by hand. And remember to make it nice and curvy. Okay, I don't mean that kind, but don't make straight lines, because I know students will do that. They'll like connect the dots. Well, in this case, it did kind of work out, but I could do it better anyway. Just that last area. Everything was good right up until that point. Close enough. So again, it doesn't have to be perfect, okay? But oh well, it is what it is. Nothing funny with the domain. And range, looking at our vertex, we know that it's going to be a 0.5. Now, the only thing we have to do is find out which way the mouth is going to be opening, which in this case, we want values less than or equal to 0.5. So and you can also check it the same way you can check it with the other one. So let's plug in -4. -4 is less than 0.5, which is true. So if you plug it in and it's true, that's good, because I know sometimes I can imagine some students being like, oh no, which way is it going to go? Okay. Now, we have a piecewise function. So I'm going to graph the piecewise function the same way. And this is a good review because we're going to look for what I call the rule change line. Now, this is not the axis of symmetry, even though I mark them very similarly. Remember when I said when we do the rule change line, we erase it afterwards because it's not part of the answer. And in this case, we are going to go ahead and do that. So both rule changes happen at -4. So this means there are no gaps. There's not going to be a big opening between two of those numbers. And I have a linear function. So start from 5. So this is the y equals mx plus b. And follow the slope up 2 over 1. But you know what? We don't need to go that way. We got to go backwards. So I'm going to make both of them go backwards. So down 2, back 1. Down 2, back 1. Down 2, back 1. Down 2, back 1. But I don't need the line to go that far. In fact, I kind of want it to stop and end right here, because we don't go past the rule change line because we don't need any of this stuff right here. While we're here, I'm going to cap off the line. And in this case here, I'm going to use an open circle because there is no or equal to portion of this inequality. So this line only goes to about like -3.99, or actually, no. It'd be like 4.01 or something like that. Okay, it'd be a really small amount, but you just have to go a little bit over -4, or in this case, under. Okay, next part is going to be graphing this thing here. Since it's a parabola, we're going to graph it the same way we've been doing it the whole time here. So that would be to find the axis of symmetry. So get our b value, which in this case is 3, or -3. Even though it says positive, remember the formula says that you should always put a negative in there with it. 2 times 1. So this would be -3 over 2. And just to make things easy, I'm going to go ahead and convert this into a decimal of -1.5. So I know the axis of symmetry is going to be at -1.5, which in this case I wouldn't. No, I'm going to just steal this. I might just steal this line here because we don't need it. And like I said, it's not part of the answer for a piecewise function, but it can be used for a parabola because it is one of the key features of a parabola. Now, I'm going to go ahead and put -1.5 in here, and I'm going to go number up and number down. So I'm probably going to end up building a table. But in this case, what I'm going to do is I'm only going to number one side, and I'm only going to go to -4. because if it's symmetrical, I should get the same numbers on this side as well. I'll show you what I mean in just a second. So I'm going to make a table here. Okay, not a very good table. It's all crooked. Okay, as long as we at least get our numbers. And I'm also going to need the same table so I can plug in my values of each of those. So let's go ahead and plug in for x squared. So -4 is going to be our first number squared plus 3x, which in this case, x is -4. So we're going to find out our first. So if we put in -4, what do we get out of it? And I want to put -4 in there because, again, that's where our rule change line is. So -4 squared is 16. 3 times -4 would be -12. So this would be 16 minus 12, which is 4. So I can graph the first point. So back 4, up 4. All right, next number is -3. So I'm going to plug in -3, and let's see what we get. So -3 squared is going to be 9 plus, in this case here I have -3 times, okay, hold on. Okay, 3 times 3 is 9, but then it's going to be negative. So I get 9 minus 9, which would be 0. And then -2, so I'm going to put -2 in there. -2 here and here. So this is going to be -2 squared. That's going to be 4 minus 6. 4 minus 6 is going to be -2. And then I'm going to plug in 1.5, -1.5. And for this one, again, I'm probably going to end up using a calculator just to make things go a little faster. So if you have a dumb calculator, or if you're watching this, you most likely would have Desmos anyway. You can use Desmos as a regular calculator. In fact, I'm going to go ahead and show you that right now. But for just a regular calculator, I'd put 1.5 times 1.5. And actually, I used to show a lot of Desmos because some of the testing, which actually is coming up very soon while I'm on the subject, because we are going to have testing. And normally, in a normal year, that would be the one where you all go into the computer lab and work it out in the computer lab. So I can easily just push that same square button I use for typing in the regular number. And in this case here, it's going to be on the out. No, there's no negative, okay? Oh, no, there is a negative and it's on the inside. But I end up getting my answer right here. So again, if you were taking the test, Desmos would be what you would have. So it's good to learn how to use it. So in this case, I can see my output would be -2.25. And now I can go ahead and graph this, at least on one side. -3, 0. So start from here. 1, 2, 3. -2, -2. And then -1.5, -2.25, which should be a little bit higher than that. And then I'm just going to mirror each of these points over to the other side. So it's about, let's see, 2.5 here. So go 2.5 this way. And that should be enough to draw your parabola. Now, I'm also going to draw it by hand here. There we go. Just because if I tried to use the arc tool, it wouldn't work as well. Did the first one really nicely. All right, very not bad. Okay. And then from here, again, no wacky business going on, so all real numbers. Range, however, that's kind of a hard one to tell because I think there's a slight jump from here to there. So starting from the bottom and working your way up. So from negative infinity, we go up to, so we want y values less than or equal. Well, in this case, there's no or equal to. Oh, sorry, the top one. The top one. So in this case, there would be no or equal to because there's an open circle there, and that means you cannot pick 4. So in this case, since you cannot pick 4, but you can go almost up to 4, that would be no or equal to. And then you would have the union symbol in this case, because there is a jump from here to there. It's a little tiny one, I think. Oh, wait, sorry. Oh, negative 4. Okay, that should be negative 4. I don't know how I missed that. Almost missed that. Anyway, so from here, we would start from y values greater than or equal to negative 2.25 again. Oh, okay, so there's going to be 2 ranges, and again, there's a jump there. So looking at your vertex, it starts again here and then continues back upwards. So that one was a bit of a tricky one. And again, if a range is really tricky like this, don't sweat it. Try your best, because I know sometimes it's just tough to get the right range. Anyway, so it looks like that's going to be it for today. All right, so that's it. And we'll go ahead and continue the second part of the packet tomorrow. So that's going to be the same thing. It's going to be a lot of the same data, but we're going to be using inequalities. So it's going to be the same thing, but you're just going to have to shade one side and use a dash line for certain types of lines, but largely it's going to be the same thing. So I will see you tomorrow. Thank you. Bye-bye. Thanks for showing up.